we said it is transport of iodine. Step number 2, oxidation of iodine through the peroxidase and hydrogen peroxide as well. This is inside of the cell. Sorry, this is at the membrane, just when it is released outside. Now, how iodine will go to the outside of the cell, to the colloid? It has actually another transporter. This time it's called pendrin. So please, there is a difference between the NIS and the pendrin. Okay? Don't make the confusion. Pendrin will transport iodine from inside of the cell to where? The colloid. Whereas the NIS will transport it from the extracellular space inside of the cell. So, one iodine is transported inside. Then, as long as it's released in the colloid, it is oxidized by the peroxidate into I3 minus or I0, or we call them the nascent iodine. Now the iodine is ready to bind to what? Tyrosine. Okay? Now, every time you have one tyrosine with one iodine on it, you name this monoiodotyrosine. Monoiodotyrosine. It has one iode on it. Monoiodotyrosine. However, you can have tyrosines with more iodine. So if you have two of them, it's going to be called diiodotyrosine. So either it is mono or it is di. Now, those mono and di, actually, they can be combined together. So if you have a combination of one mono and one di, this will give you the triiodotyrosine, either this one or that one. If you have two diiodotyrosines, you will have the thyroxine, or what we call T4. So T3 and T4 are for tyrosines, that they came from this thyroglobulin, but it refers to how many ions they have on the tyrosine. Either they have 4, they're called thyroxine, or they have 3, they're called triiodo. Now, the question for you, why don't we have here T2? Because look, we said if the tri and the di will complex together, we'll have tri, right? And if we have two di, we'll have the tetra, right? Why don't we have di here? Excuse me? Because you will never see two monoiodotyrosine complexing together. So you will never have a T2. Either it's going to be T3 because it's going to be the diiodo plus one monoiodo, or it's going to be two diiodo to give you the tetra. You will never see two monoiodotyrosine complexing together. Now, it's very important to know that in the circulation, T3 is way more potent than T4. When we get to the biological effect, the main biological effect of the thyroid hormones is actually dictated, or it is being produced by T3 rather than T4. Why? Because T3 is more potent, has higher affinity to all the receptors, and we're going to see this later on during the chapter. Having said that, T3 and T4, both of them, when they are released, T4 can be still de-iodinized. What does it mean de-iodinized? It's going to lose one iodine, so it's going to be transformed from T4 to T3. So the major form of release of the thyroid hormone is mainly T4, only 7% T3. But on the way, they lose one iodine, there will be all of them T3, and T3 is the most potent thyroid hormone in the body. But still, we did not finish yet the formulation of the thyroid. So we said, first of all, transport of iodine, second, oxidation of I minus, right? Now, after the oxidation of now we are in the follicle. Number 3, the binding of those iodide to the thyroglobulin with the help of peroxidase. They call this organification of the thyroglobulin. So you have here a phase called organification. So you have I's will come and bind to the thyroglobulin. Now thyroglobulin, we said it is in the follicle, right? It's here. How come we have the thyroid hormone secreted in the blood? What is the communication between the colloid and the blood? To my understanding, there is no communication. It's englobed, it's a bag, right? Exocytosis and endocytosis. So once the thyroglobulin is being organified, it has the iodine on it. Those cells, they have expansion of the cytosol, like the lamellipodia when the cell will walk. Yes. They will have extension. Those extensions will englobe the thyroglobulin. Englobing the thyroglobulin will move the vesicle inside of the cell itself. Now, inside of the cell, it's very important, you have the vesicles. Those vesicles, they have thyroglobulin organified. It will be fused with lysosomes. Can you remind me what is the function of lysosomes in a cell? To lyse what? It is full of proteases, right? What does it mean, a protease? Breakdown of proteins, right? So they will break down those thyroglobulin because we need with the tyrosin, right? Those amino acids that have the iode on them. So those proteases in the lysosomes, you will have protease activity. And now you have inside of the cell T3 and T4 free in the cytosol, and they are ready to be secreted. And the secretion is not by exocytosis. T3 and T4 are lipophilic. They can just diffuse through the plasma membrane from inside of the cell to outside of the cell. So let's recapitulate a little bit. First of all, the cells, the follicular cells of the gland will have to trap iodine, right? They have to bring it in. So, first of all, transport of iodine inside of the cell. Second, well, which is not second, it is there all the time, you have the thyroglobulin already synthesized in the endoplasmic reticulum, and it's exported through the Golgi vesicles inside of the follicle. It's inside of the colloid, it's waiting there. Then this iodine is transported by a co-transporter called pendrin, is gonna bring it inside of the colloid. Here you have a peroxidase waiting, an enzyme. This peroxidase will use H2O, and then it will oxidize the iodine into I3 minus or I0, and those two form only can bind to the thyroglobulin. This binding of iodine to the thyroglobulin is called organification. Once the thyroglobulin is organified, it has now to go back inside of the cell. How does it go inside of the cell? You have what we call pinocytosis, you have those expansion from the cytosols, will englobe the thyroglobulin, bring it inside. Once this vesicle is inside, you have lysosomes will come fuse to this vesicle. Then the fusion to the lysosome to this vesicle, definitely the vesicle has proteins, thyroglobulin, and the vesicles, they have proteases, they start chopping the thyroglobulin. Chopping the thyroglobulin into what? Tyrosins, amino acids. But those tyrosins are way different than the tyrosins that they made originally, the thyroglobulin, because now they have iodine. They are already organified. Now these T3 and T4, they go into the secretion, and the hormone can go and do what's supposed to do. Sometimes when you have the cut with proteases, you do not release one tyrosin. You will have still two tyrosins combined together. Will they go into the circulation? No, they cannot. They are recycled inside of the cell, and there is a deiodinase. It will come, remove the iodine from them. So they are amino acids again, tyrosin amino acids. They are available again for the endoplasmic reticulum to generate more thyroglobulin. Are we clear until now? Now, question for you. If this process is a one-shot, it's none or all. Either it works in synergy, or any breach in one of the phases will lead to defective thyroid gland. Is that clear? Now, some people, unluckily, they have genetic problem with the transporter. No iodine being trapped. Can you have thyroid hormone?
No.
What would be the problem of not having a thyroid hormone? Do you know? Hypothermia, low metabolism, sleepiness. What? Cold. We said hypothermia. Okay, bad mood, excellent. Guys, before you get to these, if it is a hereditary problem, it means the baby won't develop. So it won't get to the stage where it has a bad mood or not. All right? And this actually requires an immediate intervention in medical practice. The person has to be on thyroxine pills for life, because thyroid hormone is very important for the development of your body. If a baby is born with this genetic defect, it means since the minute he's born, he has no thyroid hormone secretion, right? So what will happen to him? He won't grow. So he won't get to a point where he's going to feel cold, or he's going to be in good mood or bad mood. You understand? Now, on the way, during adulthood, it does not mean that you can have problems with thyroid gland. You can be diagnosed at the age of 50 with problems with the thyroid gland. This is different. We're going to see some example after. Some people, bad enough, they have problem in the pendrin transporter. So iodine is getting trapped, comes inside, accumulates in the cell. It cannot go outside of the cell to the colloid. So there will be no organification of the thyroglobulin, right? Therefore, there will be no synthesis of T3 and T4, or thyroid hormones. Same thing when you have the iodinase, what is it? The peroxidase. Some people, they have defective peroxidase enzyme. Same thing. You have iodine trapped, no problem. Pendrin, no problem. Went to the colloid, no problem. Where's the oxidation of iodine? No oxidation of iodine. And remember, only thyroglobulin will bind to oxidized iodine. In all these cases, as I mentioned, the patient is treated by taking orally thyroxines. this is a summary again for all the steps